LLMs are linguistic engines, not calculators. The pattern that works is simple. LLMs compose, specialized systems execute. The companies winning with AI figured this out. The rest are waiting for magic that isn't coming. Let's start with a puzzle. 88% of large organizations now use AI somewhere in their operations. Yet, only about 6% see meaningful profit impact. That's a massive gap. Everyone's using it. Almost no one getting real value from it. Why? We want to frame this with a historical parallel, because we've seen this pattern before in 1956. A trucking entrepreneur named Malcolm McLean loaded the first standardized shipping containers onto converted tanker in Newark, New Jersey. This was the birth of containerization. Before McLean, the cost of the ship load was $5.86 per ton. After, 16 cents. A 36-fold cost reduction. Loading time went from 8 to 10 days down to 2 days. But here is the thing. It took decades for the industry to fully realize those gains. Why? Because people didn't understand what they had. They thought of containers as better boxes. They tried to feed them into existing port workflows. But the real revolution wasn't the box. It was the standardization that enabled completely new processes. You need new ports, new ships, new cranes. The unions fought it. The regulators fought it. Everyone tried to preserve the old way of doing things. And AI is the new container.
A senior partner at a major global management consultancy made exactly this comparison. He said, I always compare it to the invention of the shipping container, something that changed global flows of goods, made it more efficient, easier, standardized. I see that now with Gen AI. So what's the equivalent of using containers as better boxes? It's thinking of LLMs as really smart calculators. I've got this super intelligent thing. Let me ask it to crunch my numbers. And that's exactly backwards. Completely backwards. A former CTO of a leading supply chain optimization company put it really well back in 2023. He said, LLMs are terrible with numbers. His advice? Don't ask an LLM a mathematical problem. Ask it to phrase the problem and then pass the computation to something designed for that, a Python kernel, a specialized solver. Here is an example of where this goes wrong. Ask ChatGPT to list prime numbers or do compound interest. It will get some right, hallucinate others. It looks confident, but it's pattern matching on what prime numbers look like in its training data. It's not computing anything.
That's wild when you think about it. These models write poetry, pass bar exams, but struggle with multiplication. Because they are linguistic engines, not calculators. They predict the next token. They are phenomenal at language. Math just happens to be expressible in language, so there is this illusion that they should be good at it. So, when somebody says, I am going to run my supply chain through an LLM, they are trying to use a container ship on a horse-drawn cart path. They are thinking about it in the wrong way. And that wrong thinking is why we have this 88% adoption and only 6% impact problem. Let's break this down. What's the right mental model for thinking about these different tools? There is a nice framing from practitioners who've been in trenches. There are basically two categories of model in the AI world. On one side, you got your numerical models regression, Monte Carlo simulators, neural networks trained for specific tasks. They plug into the middle of your business process. Data goes in and numbers come out. That's your traditional machine learning. Forecast demand, predict churn, optimize roads. The output is numbers, and you act on those numbers. And then LLMs are the other category entirely. They work with text. And here is the key insight. They plug directly into human workflows and interactions, not in the middle of data pipeline, but the places where people are reading, writing, communicating.
So you have different insertion points into the business, completely different. And that matters because the value proposition is different. Numerical models make your automated processes better. LLMs make your people more efficient at the tasks that involve language. Drafting, summarizing, searching, communicating. There is a great line from an experienced software architect about having a private department of assistants, polyglot, full stack, sometimes naive, but intelligent, and they never complain. That's the right metaphor, not a calculator. An assistant who is really good with words, but you wouldn't trust to do your taxes. Okay, so if LLMs aren't good at computing, how do you actually use them for problems that require computation? This is where it gets interesting. The answer is mediation. You don't ask the LLM to solve the problem. You ask it to compose a program that solves the problem. Write me the code, not the answer. The CEO of a quantitative supply chain software company made this point really clearly. He said, for most problems, the right approach is to say, please compose a program that will solve this, not solve this for me.
And then what happens? The LLM produces a program. Could be SQL, Python, whatever's appropriate. Then something else actually executes it. A database runs the SQL. A Python interpreter runs the code. The LLM never touches the actual data or does the actual computation. So it's like the LLM is the architect, but you need actual builders to construct the build. And here is what's clever. If you give the LLM access to a compiler or interpreter, it can see if its program works. Like ChatGPT's advanced data analytics feature that does exactly this. It writes Python, runs it, and gets an error. Fixes the code, tries again. It does self-correction. The LLM is great at understanding error messages and adjusting. That's text processing. It's in its wheelhouse. So you get this feedback loop. Write code, run it, see error, fix code, and repeat. This is a very powerful tool.
And the end result is you get to leverage the LLM's intelligence without trusting it to do the math. You are using it for what it is good at, understanding intent, generating structured text, while delegating computation to tools that are actually reliable for computation. This sounds great in theory, but here is the question. Does this require your systems to actually support being programmed? And there is the rub. This is where that 6% impact number comes from. One supply chain expert put it really bluntly. What programmatic environment can you provide to the LLM? For most companies, the answer is nothing. Think about a typical ERP system. You log in, navigate menus, click through the screens, manually enter values. Maybe you are setting safety stop levels, product by product, screen by screen. Now imagine you have 50,000 SKUs. That's months of clicking.
There is no API, no scripting language, no way for a program to say, adjust all these parameters according to this logic. The LLM can write you the perfect optimization recipe, beautifully reasoned, technically sound. But to actually apply, someone has to sit there, clicking for weeks. So the LLM becomes a brilliant advisor whose advice you can't follow. A data scientist at a major automotive manufacturer described one of their supply chain tools. It has 21,000 different constraints feeding into it. 21,000. That's exactly what he said. No human is going to manage that. Humans were managing it, but not like managing it, more like move from left over to right. This kind of management. Not how should I reorganize this information so that I am making a better decision. There was simply no way to organize that information in the way where a human could make a good decision. The complexity was not the question itself. Supply chain questions are simple. Where should this thing go? The complexity came from the sheer size of the problem.
So it's not that supply chains are inherently complex. Supply chain decisions are extremely simple. Allocate resources, move things around. It's not abstract. It is physical and tangible. But large companies organized a division of labor, and suddenly what was one simple decision got split across 20 different functions. The complexity is synthetic, created to support the organization, not because the problem required it. As one practitioner agreed, there is a lot of made-up complexity that's there just because of the size of the problem we need to solve. And this matters for AI, because when you finally deploy something that cuts through that complexity, you need to actually act on what it tells you. But if your systems don't support programmatic action, you are stuck. Deloitte found legacy system integration is the number one blocker for deploying AI agents. Nearly 60% of organizations cite it as their primary challenge. Not data quality, not governance, just AI can't touch our systems.
The AI has the answer, but can't implement it. It's a genius consultant who is not allowed to touch the keyboard. AI advice, not action. And that gap between what AI Cloud recommend and what you can actually implement, that's the real bottleneck. So the companies that 6% see the profit impact, they are ones who build the infrastructure. They have APIs, they have programmatic surface, they have systems where the AI can actually do something. The ones stuck at 88% adoption and zero impact are waiting for magic that requires infrastructure they never built.